So this one is a prototype of the furnace systems that I try to make. So the first versions I make a physical prototype of the furnace. This one I make is air controller logic. So pretty much we see here is that the major part I have a inducer, I have a gas valve, flame sensor, just to represent the flame sensors since I don't have flame here. So this light here will be the flame sensor. And the last one is the flame, blower fan. The logic is that we're going to detect the power coming in using this autocoupler here. The power when autocoupler is going to sense the power coming in, and this signal will send to these Arduino board. The Arduino board detect the signal when if they signal power coming in, it's gonna send the output signal to the relay here to trigger the device on. Then the power coming from the outside will be connected and sent to the inducer fan, the gas valve, the flame sensor, and the fan blower. It's pretty much the ways in the real life we have different kind of sensor, right? And the sensor will send a signal to the processor here. The processor is going to decide since everything's and decide the sequence and also make the related decisions whether to turn on the damper or to shut off specific part or to increase the fan speed. Also, I have this air controller board, the dashboard here. As you can see, there's a different. It detects different sensor and the status of the system, like user, gas valve, flame sensor, blower here. And they have a dashboard seeing all the log of the system at a real time, humidity sensor, temperature, inducer, gas valve, flame, and status of the system. Different status of the system like purging, running, or ignitions is gonna show in the dashboard. And then if the system is locked, for example, or any kind of part is failing, it's gonna show in this dashboard. Also, I have a testing abilities of the system, this button here to turn on, turn off specific device. For now, I only have two devices I can test, inducer and the flame sensor. But then in the real system, the technicians can have like multiple buttons as long as they have strong enough power supply and their microcontroller. So let's start with the sequence then. Plug in the power, and I'm gonna turn on the system. Fan blower, inducer, and then relay clicks to the gas valve, and this flame sensor coming in, and relay just here the fan blower. For example, I have inducer arrow. This inducer turning off, the whole system gonna cut off. Okay, and I turn it on again. You see is that when the system is turned off, all the system lock gonna show. Let's see, yeah, and is everything is working wirelessly. Very easy for a technician to diagnose the system without having to touch it. Turn it on again. Right. see the gas valve is turned. Then flame sensor. But what happens if a flame sensor have problem? This doesn't detect any flame inside the system. Let's test it. I click here. Turn on the flame sensor. So system gonna retry. You see that the dashboard here. You see the CPU retrying to purging again, igniting again. There's no flame. We're retrying. The system is retrying. Okay. There's nothing happening. As system lockout. It's represented real life scenario when there's no flame happening. The system will go to the hard lockdown mode. Technician have to come to reset the system into the original. So that's pretty much my demonstration of the air controller board prototype made by me. And yes, as some additional information is that the system is designed to isolate the air controller board, the main processor with external high voltage environment, right? That's why I have the design of autocoupler and autocoupler relay. So 120 volt will not, or 110 volt, 200 volt will not in contact with the main board. So anything happen on this side here is separate. The node is separate. This protector, the air controller from the world. So the air controller will not be fried if there is a short circuit or the kickback of system. So pretty much it. Thank you very much.